So we're going to do a short demonstration here on how our MF control valve works. You can see we have it mounted onto a 5.7 liter hydraulic skid with a 74cc hydraulic pump. This valve effectively splits the flow from the pump in between two circuits. On this particular setup, we have, with our engine dyno, we have a motor set up to simulate a wellhead drive system, and we have one of our blower compressors set up on the second circuit, and we will adjust the pressures on that one as well. So on the valve itself, you can see the three gauges. You have your system pressure gauge here, A circuit required pressure, load pressure, and B circuit required pressure. The two control valves, here's a control valve for your A circuit, control valve for your B circuit, with the coordinating cards as well. So we'll start this engine up. Also, we have up here our controls for our A circuit and our B circuit. That's our speed control. So with our bypass valve open, we're getting no pressure because we're in bypass mode. So we close our bypass valve just like you would on a regular well. Now you can see on our system pressure, we're running at our load sense of about 250 psi. Our well is not turning. Our blower compressor is not turning. With the engine at idle, we can adjust our A port, which is our well. We'll see that our pressure will start to creep up. Our well starts to turn. Our RPM is too low to read right there, so we'll get it up a little higher. So now we're reading just under 100 RPM, about 100 RPM there, roughly. We're not showing much load pressure on our A port, but our load sense has come up to about 300 psi. So we're taking about 50 psi to run that. Our B port is doing nothing because we haven't turned it up. Once we turn our B port up, see that pressure will start to climb, and the corresponding system pressure starts to climb as well. The pressure on the A port does not change. So that's telling us that our blower is now running. Our system pressure has come up to compensate for the increased load, but the pressure and the speed on the A port has not changed. It's still running the same RPM. The engine RPM is still at idle. Once that revs up, you'll notice that those pressures will not change and the RPMs will not change either. I'll just take you around here and show you the blower running. You can hear it running, you can see it running through the guard. Our engine's just going through a warm-up phase here. In another minute, our RPM will come up, and then we'll go through some more tests. The other thing, we can adjust our pressure on our well here. Put a little back pressure on this. So now you can see our system pressure is still the same, but our A pressure is changing. But our system pressure hasn't changed because the A pressure hasn't got high enough to affect that. If you drive it up higher, then the system pressure goes higher to compensate, but the B pressure does not change, meaning the RPM does not change on the B circuit. You can see, even with fluctuations, the B pressure does not change as the A pressure fluctuates, simulating a well torquing on and off. You'll see that better when we get the engine RPM up. There it goes. You can see your pressures have not changed. B pressure is still the same. A pressure is still down. And the RPM is still running the same RPM that it was before. We're gonna show you a tach RPM here on the blower. That's not good. If we can get a good reading there, it was running about 1100. That should be right. That 51's not going to be right, but there again, you can see the RPM on the blower has not changed because the pressure hasn't changed on it. Let's go over this a little bit more. So you can see our RPM there is about 880. That should be pretty close, I think. But as we fluctuate the pressure on our A port, nothing on the B port is affected. So again, we'll speed up our A port a little bit, get our RPM up a little higher. So there we're running just under 500 RPM on the outside ring there. Our system pressure is still at 700. Our A pressure is now about 350, 400. And our B pressure is at 500. As we put some load onto our A side, well load, our system pressure comes up to compensate. Our B side pressure does not change, which is exactly what we were trying to accomplish. As this pressure fluctuates, B pressure doesn't change. Maintains the flow rate and the speed on the B circuit. The same can be said for the A circuit. If we were to fluctuate the pressure on the B side, the A circuit will not change. We'll simulate that here right now. Our RPM hasn't changed on our B circuit. We changed the pressure on there, it hasn't changed. We'll adjust the pressure on our B circuit now and show you that the pressure on the A circuit doesn't fluctuate. Like, just come and adjust this valve here. So we'll just open and close that. So as he closes our discharge valve over there, you'll notice our pressure will come up and our A circuit pressure does not change. And our speed on our A circuit does not fluctuate. It stays the same the whole time. So that's telling us that our valve is controlling those two circuits independently from each other, which is exactly what we're after.